Okay, so I will start with a little bit of like the history. When did ARM start in this kind of type of devices and so on. Then I will go a bit more into the details about like how the current installation does look like. So why I'm going into that, you will see, because it's more cumbersome than you would actually hope for. And then what is the upstream support for especially one particular device that I have with me here. And then what happened to me when I tried to daily drive that, what is the known bugs, what are the limitations, and all these kind of things. So we had a BOF yesterday on that one. So if you have been at the BOF yesterday, I don't know how much new information I have for you, but still stick around. I might have something that you haven't heard about yet. But if not, yeah. So what are you having? So history. So these compute devices are not really new or anything, right? So ARM has been like in this space for a long time, but it just was at that point, starting like something like 2007 or so, it was been netbooks. So a lot less powerful than what we have. When I moved houses last year and I looked at all my cupboards and everything, I found one of the very old, I think IMX-based netbooks I had at that point. It's still there. Obviously, I don't use it anymore. But this remembered me really like what a long time ago actually these kind of type form factor devices already have been there, but in a very different scenario. So and then that scaled up a little bit, then we had the ChromeBooks and everything. So that was really going into in the areas where people are really started to use it a lot more. They have been like in the millions of hands to actually try that out. But for a developer's perspective, or people looking for like a more premium device to do their all-day development and all-day usage of that, then I think the most prominent point was when Apple decided to go full Apple Silicon and bring out their first M1 MacBook, basically. So that's like 2020, around that time. And then other parts catched up. So for example, the ThinkPad X13S is a Snapdragon device. First one with Windows, not the first one, but it was one of the more prominent ones with Windows on that one. So I think at that point, the speed was kicking up a little bit. And then last year, there was a big launch of these X Elite Snapdragon devices, which a lot more devices being available to the public at that point. So one word of notice here. So I'm not really involved in any of the other Linux projects. So whatever I talk about that front is like really just an outside view for me. So I researched that a little bit when going into this talk, and I wondered like how does it look, how they spin that off. And I was a bit surprised when looking at their progress reports, how many lines of code, how many patches they actually have externally. I know that a lot of that depends on the Rust side, where they have like developing drivers in Rust, and the infrastructure and kernel hasn't been there to really upstream all of that and so on. I see that they do a lot of like work to get that sorted out. For example, the UEFI that just recently merged to get like their Mesa fork done and so on. And from what I heard from people actually using it, they don't really mind that as long as they are not kernel developers that want to like really develop and get the whole patch set rebased on something more recent like an RC kernel or something like that. If you're just a normal user and just use their spin-off of the distros or something like that, that's normally not a problem at all. You can just daily drive that and you're quite happy. But if you're looking at that from a developer's perspective, that it might be a bit more problematic here. Yeah, but they promise, or they're really looking into focusing a lot more on the upstreaming side to get rid of all these amount of code they have been sitting outside there. So on the one hand, we have the Apple Silicon, which is like a big part of like the ARM-based devices on the laptop space. And then since like 1 year ago, so last year in June, there was like this big push coming out, the X Elite Snapdragon devices. And with the launch, actually, there was like, 8 manufacturers and over 100 devices in all kind of different SKUs, obviously, being available. So that was a lot like interesting part because you had like a big choice of devices. So it's your personal taste if you want to have like a Lenovo or a Dell or like a specific color scheme or like high price, low price or whatever. So you have a lot more options available at that front to do that. But obviously all of that has been designed for Windows on ARM. So all the things we're talking about here on the Linux side have never been set as a record they want to do, they want to bring that out. It was always focused on ARM, and then the idea was to like how to get Linux running on that as well. So that's the first point basically I made already. So Windows on ARM, that's the focus, and that is something that is obviously making trouble to us later on, because if you haven't been in in the group that is designing something like that, you're always like trying to catch up, figure out how they do it, why they did it that way, and how to get it supported. So one of the first things that is problematic here is the whole setup they have with UEFI booting and ACPI description. So the ACPI implementation they have on these devices is using quite a lot of these so-called platform extension plugins, which is basically code that is running on the Windows side. So that is not running on the ACPI side. So it does not allow to like discover devices, discover like how the tables are set up. And a lot of these tables are actually missing. So when we tried out to get Linux booting on that one with ACPI, which was the first choice to try and figure that out, that proved to be impossible. So there's just enough stuff missing there that we can't just go and do an ACPI Linux boot on these kind of devices, which is a problem. And yeah, but that was like part because it was designed for Windows and it wasn't designed for Linux or anything like that. So basically that means we are falling back to DTB, device tree, which is fine. We are using that on ARM all the time. We're using it on all the embedded devices and so on. So why don't just go with DTB? The problem here is, and I go to that in the next slide as well, you need to provide the DTB in one way or another. And in this case, there is no provisioning of a DTB, even like a base DTB or something like that, in the firmware. So you need to bring that in the installation to actually make sure that the kernel can boot and detect all the parts of the device to actually boot up. And then there are some other smaller issues that we have been seeing. So for example, in the higher end spec devices with like 64 GB of memory, Grub had problems to really go through all of that, finding the right spots and so on. So you had to really limit it down to like 32 GB to really figure out, okay, this can really boot up at that point. So there have been smaller things around that, but yeah. Okay. So I touched on that before. So how's the whole installation going to be? Normally what you expect, you get an ISO from your favorite distribution, put it on a USB thumb drive, and then put it in, boot it, and you're actually ready to go normally. That is a bit more problematic here. So you can't just do that because the installer has no idea what the hardware is actually about. So it would need to have a new kernel, most likely, depending on the distribution. It might actually have a kernel supporting that already. But besides that, you also need to have a DTB inside the installation mediums. You might need to augment that. Some of the distros, some of the niche distros actually ship that, but the major ones don't have it like for all of the devices available. And then you also need to make sure that it's selecting the correct one. So how are you doing that? So what is the mechanisms to match a DTB to the given hardware, right? That is a problem that we still are looking into to solve. Right now, all the installation media you see have been augmented one way or another to make sure you have the mapping correctly in the entries for the boot, where you say that this is the correct kernel image for that, and that is the needed DTB to make that all work. One way to bundle that a bit more nicely together is the idea of having unified kernel images. That comes mostly from the systemd and security world, where they want to make sure that you have a kernel image, initRD, a kernel command line, all these things into one file, a UEFI PE file, and then they can sign that off to make sure that people are not changing the command line and all the security mechanisms are not in place anymore. But they can also use that for shipping a DTB. So basically what you can do, you can have like a kernel image, initRD, command line, and a DTB all bundled in one file. And that would actually make it a lot easier to like make sure you have like the right combination of files to boot up. And that brings us back, so okay, so this is supported in systemd boot, but there are also patches for grub. I think they have been posted to the mailing list. I'm not sure if they are completely reviewed and merged yet, but this is a functionality that could be used. But that still makes us wonder how we are mapping a specific device to a specific DTB or UKA file at that point. There's something called the computer hardware IDs, just chips, basically that allows you to have like a specific ID that you can map on these kind of things. Sadly, that is not covering all of the different SKUs that are available. So sometimes you have like a different screen, you have like a normal screen or an OLED screen that might need a different driver or need something else in the kernel to take care of that. And some of the vendors have mechanisms to to determine that by reading some bytes of memory to identify the specific SKU of the device, or having like a specific GPIOs or something like that. So there's a lot of like device-specific knowledge you need to build into that. So that's something we are still battling with to figure that out, how to do that in a way to scale for the distro to install that. One alternative could be to have a specific image running, and that would run just a normal ISO image or something that would write a specific string into a UEFI variable to make sure that you know what kind of device it is, maybe a specific ID or something that could then later be matched to the DTB, to the kernel. So, but that's all very much work in progress. Right now, I would say we don't have a scaling solutions to really bring all these devices in all the different distros and make sure everything is working out of the box. That's still something we work on. That doesn't mean you can install it, right? That's still possible in everything. But like for a very smooth installation where you can just go grab an ISO from your favorite distro and be done, we are not there yet. And by the way, if you have any questions also, feel free to interrupt me at any point, right? So just raise your hand, I will bring you a mic, and then we can get. So the upstream support. So upstream support has obviously different levels, right? It can vary quite a bit between the different devices, but in general, the common SoC support that we have in the kernel, that is the base for all of that. And then you have the more specific parts for the devices. To have like the device description for all of them, and sometimes you need like specific firmware or specific quirks or something around that. But in general, the SOC is the first part of it. And you also need to make sure that the firmware that you need, or you don't need to make sure, but it makes things a lot easier if the firmware that is needed for these kind of devices is shipped in Linux firmware, to make sure that everything is also, again, for the distro being available at that point. And then for these specific devices, you have something called PD Mapper. There's a user space service, but we also moved into a kernel version yet that should eliminate the need for another service running in user space just for these specific devices and so on. So we're doing a lot of Qualcomm work for many years now. And we have a heat map. So the first link basically goes to the normal heat map describing all the SoCs we are supporting and like how the support is in upstream for that one. But that is more like the generic view on what we're having. And then for the T14S, for example, the device I have with me here, there's a more detailed look into that. That is something Johan is having a wiki about. So if you look at that, if you look at all the green stuff, that looks pretty good already. So you have like audio is working, backlight is working. For Bluetooth, there's some problem. I mean, it generally works. So every time you see like the WIP branch, that is basically something, a branch we have where some patches that haven't been upstreamed yet completely are sitting, maybe like an integration branch, basically, right? And we also started work on camera and all of these kind of things. And you can see this work started in 6.12 already, and the latest stuff has now merged in 6.16. And some others are missing. So if you look at the ones that are yellow, so we're just not completely done yet. As I said, Bluetooth, that's something mostly about the power sequencing, how to enable and disable the specific devices. For camera, the basics are there. We have code actually in the work in progress branch to enable that for T14S, I think for the Dell devices as well, but maybe not for all of them. So that really depends on the different camera sensors and how they are hooked up into the device. RTC, I think, again, we have like patches for that, how to handle like a specific offset to make sure that we have the real-time clock that is sitting in there. The thermal sensors, I think we are waiting on some of the core patches for the PMIC drivers to read the sensor values out and then feed that back into the thermal system to have like different thermal zones and define like how Linux should react on if the heat goes up in a specific area, like throttle the CPU or something like that. And video acceleration, so that's something to offload your video decoding or encoding. That's also something we have working, but it's more like for specific devices we have not enabled for all of them yet. So as you can see, there's a lot of good stuff and a lot of things that you can use it as a daily driver with quite some things that you need to keep in mind. But in general, the hardware support for that is quite good. So, but what about beyond kernel? So, yes, it's nice if you have, oh, sorry. There you go.
Hey, sorry, I was just wondering if you could talk a little bit about the status of virtualization. I wasn't sure how to interpret that on your last slide.
no problem. So virtualization. So basically, these systems come up with a hypervisor called Ganya. That means the system is not booting up in EL2, which means you are not able to run KVM or anything like that, which is obviously not a good thing. Some people want to do that, some people maybe don't care, but for people that want to do that, there's a mechanism called SL bounce, which basically is a small tooling that you would run on the firmware side, in the UEFI. You bring that up, and then it bounces back and allows you to boot the whole system in EL2. And that is obviously means you have like a different view on the available hardware because the hypervisor is not interacting anymore. And for that to actually make sure to work on Linux side, we have a few different DTBs for that being generated, basically. So now for all of the, I think that should be in 6.16. So for every device we're supporting, you have like the normal device tree file, and now you have another one called, with the same name, and then -EL2 DTB. And if you load that one, the device would normally boot up in EL2, as long as you did the manual step up front to bring it with SL bounce to bring it into this mode, basically. This is also what Windows is using on the other side. So they don't have any like of the restrictions not running EL2. They have to use the same mechanisms, basically. And someone on the community side reverse engineered that and built a tool to run that on Linux as well.
Does that break anything about their clock drivers?
On the clock drivers, why? Anything?
I'm asking because I'm supporting a Qualcomm chip right now that has a virtual machine that runs under Gunya next to Linux, and the clock drivers are kind of split, and half of them are in this virtual machine, and half of them are in the kernel.
I would need to look it up for X Elite if that's the case or not. I don't know that out of my head, but I think it's most of the stuff is more around the whole memory side and how to handle that part, SMMU and so on. That is normally what is more what we're worried about. But you can look at the EL2 DTB stuff, what they did there, how they split that off. And if not, I would come back to you for the clock stuff. I'm not really sure about that. Okay, so there was kernel. Yeah, so kernel is good. It's nice to have a device that's actually working. It's hardware supported, but you really want to use it, right? So that is something that comes out of that. And on the ARM side, you normally get products that are highly integrated. The person that is, or the company that is selling you the device, made sure that all the features they want to sell you are tested, no, more or less, but at least they are enabled and everything is working the way it should be. And on a laptop that might be a bit more different, right? Because you have a lot more freedom how you drive this device and so on. And for example, you have like the video encode decode. That's what I mentioned before. So we have the hardware support, we have the drivers for that, but really how to use that in an end-to-end fashion. So for example, if you go and open up your browser and play a YouTube video or something like that. Right now, what happened, that would all be on the CPU side. There was no hardware acceleration on any of these. Basically, it would work, but it would drain your battery quicker than it should be, right? So on the Chromium side, that was something I was looking into over the last half year or something. So there's a lot of good progress going on in that front where you can actually, Chromium can detect the beautiful Linux 2 APIs we are offering, and then make use of these kind of hardware offloading capabilities in that case. So that was something that was normally done on the Chromium side only for all their Chrome OS devices, where they had like very specific use cases for that, but they opened that up for generic Linux devices now. So that makes things a lot easier. I think I run that a month or two back, and I had like only a few patches on top of the normal Chromium to make that work. A lot of that actually was like configuration options for the build and so on. So most of the stuff is already there, so that is making good progress there. On the Firefox side, for example, we don't really have that at the moment. We are looking into how we can make sure that we can use beautiful Linux memory to memory with Pipewire or something to have like FFmpeg as a backend to offload that as well. So that is a lot of like integration end-to-end use cases that we are not covering, but we should at some point. And again, next point would be on the camera side. We have support for soft ISP, so everything on the CPU side, that is something libcamera is supporting. So I've seen the devices running, we had like video conferences with that, but it's not using all of the hardware blocks. So on the Qualcomm side, that is a bit difficult to really get the hardware fully supported. They have that like for products they are selling and so on, but not easily enough for like the community to digest that, because there are not open source parts in that one. So but what we can do is like on libcamera at least have it on the software side, and for some of the more power or CPU hungry transformations that are going on, there was a patch that posted by a colleague of mine, Brian, using the GPU to offload some of these stuff. So that has been posted. There's progress in that front as well. So for normal, I would say normal video conferencing and so, that's all fine. But if you have like more advanced needs for your camera or something, then there need to be a way to be figured out how to use the more proprietary parts from the Qualcomm ecosystem there. And the last one, which is quite important on these kind of devices, is all the whole thermal setup we're having. So thermal, while we can read temperature values in the kernel, we can set up thermal zones to like throttle maybe the CPU, maybe throttle GPU and stuff like that. You can have all of that, but there's a lot more in such a system, how they interact, how to actually make sure that you synchronize how the efforts are done. On the, for example, the embedded controller, right? That is controlling the fan for the active cooling side. The EC might also know about the temperatures in the system and has its own algorithm at what point to spin up the fan and whatnot. So this would be something that would need to be synchronized between Linux and the EC. And then another part would be the charging and battery part, where we actually need to understand like how hot that is. Are you overloading the system by charging with whatever 100 watt or something like that? And at some point it might get so hot that the CPU actually need to be throttled because the overall temperature of the device is getting too high. So I mean, the main thing is we want to make sure nobody gets like a skin burn, so you don't like have any problems with that, obviously. But also you want to have like the best performance getting out of the device, and you don't want to have the fan to spin all the time. So yesterday, for example, in the BOF we talked about that, and one suggestion was to like keep the fan running all the time. That would help, obviously. That would keep the device cooler, but obviously it also means it's quite annoying, and sometimes they can get very loud, and you don't want to work in that kind of environment. So one of my colleagues, for example, had a device that has the fan always on, because there was a firmware bug on that one, and he was never happy to put up the device to actually use it on a normal desk or something. So there's something that is a really big gap at the moment. We have access to some of the thermal data. We know the temperatures. We can throttle the CPU. We can throttle the GPU. We can set trip points to make sure the device is not resetting or anything like that. But we don't have a good way right now to have like a full system view and coordination between Linux, embedded firmware, and charging and so on. So that's definitely something that will need more efforts over time. On the embedded controller side, also, again, there comes a problem that while Qualcomm is working with us to work on an EC driver, so we can access this kind of information and coordinate that on the Linux side, that is only for their reference design. And none of the vendors does need to follow that, right? I mean, if you're a Lenovo or if you're a Dell or something, you often have like your own EC code base or like specific chips you want to use for that. You have that from another product line with x86, for example, right? You want to reuse that part. And it might be a completely different protocol you're using to like controlling all of that information. So it's very device specific how to do that. And it's either the community reverse engineering that, or the vendors really stepping up and helping to develop on these kind of things. And then on top of that, the whole thermal design of every individual product is very, very different, depending on what kind of casing you're having, how you're stacking things to each other, like where the ventilation goes through, where the fan would actually hit, and so on and so on. So it's a really big problem at the moment. We have, as I said, we have most of the things in place to not overheat the system completely, but it's definitely not running at the optimal performance for all the workloads you can give it right now. So that's something where we would need definitely more help from the different vendors to get involved. Okay, so I was using that for a while as my daily driver. So what is the cons and the pros I've seen on that one, right? So I think for myself at least, the performance was quite comparable to an x86 device from the same generation I had. GPU was very easy to like get sorted out. All the stuff was in the kernel already. The 3D Mazer driver was working fine as long as you have like the specific, the 24.2 or newer version basically. A lot of the firmware is in Linux firmware. For example, for the Lenovo device, Lenovo actually pushes that themselves, so that's good. If not, you would need to like fetch that from the Windows partition. It's not a problem, you can find the files there and then just copy them over at the right place and then you should be good as well. And then obviously I'm running a Debian on that and then all the normal packages, everything like you need for a development experience is already there and it's working. And then whenever you have like a specific like proprietary binary file for x86 or a game or something like that, there's FaxMU, which does a really good job actually to get most of the stuff running. So especially if you're into gaming or something like that, that could be an option for you to look into. For me, that didn't really apply that often because most of the stuff I work with are open source tools anyway, and they're just compiled from source for the right architecture and they're good. But yeah, the cons, I brought up that already. It cost me quite some hair, as you can see. On the installation, that is gone for a while now. So the installation was really a painful thing. And a lot of my colleagues also found that very painful. And that means for people that do embedded like for a living, that tells you quite a bit to like get that all sorted out. So that's definitely something that need to be better. And on the power saving side, also the problem is that we are not going into the full power collapse mode, which means even if you suspend the device, it's drawing quite a bit of energy. And that means it's not like staying like, it could stay like a few days in suspend if it would have that working. But right now, sometimes it just runs out of battery like overnight or something like that. So that's definitely, if your use case is that you need that a lot more, like having suspended, so that's definitely something to keep in mind. People are working on that, but I don't have like an idea of what's going on there. So firmware limitations, yeah, mostly coming from the boot firmware side. For example, these quirks with the 64 gig memory and other things. So then system instabilities, I personally haven't seen them so much, to be fair. But a few of my colleagues running these kind of devices have been seeing a lot more where things have been reset. And then sometimes the thermal was getting too high. We hope that we have fixed most of these problems, but there's still some things that are quite unstable. So for developer experience, is that still something that's okay to do? For a normal end user, I would say that's a no-go right now. Some other known bugs and limitations we're having. So we have audio enabled, but we have no speaker protection on these devices. So that means if you're trying to run that, make sure that your speaker volume is really low, so you don't like burn out your speakers or even worse, your ears or something like that. So that is something, again, that's being worked on. It's a complicated thing to like get that all sorted out with the audio DSP and so on, but that's something that's work in progress. But we at least have audio for people to try it out, but be careful if you do. Power collapse, I mentioned that already. And for the camera sensors, I think for most of the devices, we know the sensors and have the correct init sequences and everything. It's mostly a matter of like implementing that and setting it all up in device tree and get it tested and pushed out. Yeah, I mentioned the RAM as well. And only Lenovo is the only one shipping the firmware files for the devices. So I know from the mailing list, I see that people from Dell actually look at the patches they're posting for device tree and they're testing them and giving their tested by and so on. So people in these companies are looking into that, but I have no idea if they're really having like a bigger group of people actually trying to look on the Linux side for these kind of devices. Okay, so developer. So that is like quite some nice surprises here. If you develop on ARM, which something I do, it's really nice to have something like the full native Yocto builds or something, right? You have no cross-compiler in the whole thing. You have like missing quite a few steps in the bootstrapping process and so on. That's quite nice. Kernel build, yeah, the kernel with the dev config for this specific device, it's really down to like 2 minutes, so it's a really powerful device. That is quite nice as well. I was even trying out a few times to build the Chromium Debian package, which is a beast. So that's something you normally don't want to compile on your own. But even that one succeeded. So, and yeah, as I said, you have like normal, you have like the full day of battery life. I mean, not if you're compiling Chromium, right? But for normal development style, you have like a full day. You can go with that. You have like Debian tricks. So for example, you have all the images available. And there's still very much an ongoing effort from all kind of people. So Qualcomm itself, obviously, from our side, Linaro on the landing team, we are doing a lot of work on that, and the community as well. So there's still work in progress on that. I always hope it would be faster. I always hope it would be more stable. but there's still movement in the right direction. Okay, so what else do I have here? Some tips and tricks. So if you're going to use one of these devices, please make sure that you keep your Windows partition. Either like make a backup or something. It's really, I mean, at least for me, it's very tempting. Every time I get a new device, a new laptop or something, I don't care about the Windows part. I just install Linux and I want to use the full NVMe or something like that. But in this case, just to make sure you keep it, sometimes you needed to grab the firmware files. Sometimes you needed to like update some of the UEFI firmware or something like that. So just have that around. That's handy, right? And if you do that, also make sure that you disable all the BitLocker stuff, because if you want to grab the firmware files from the Linux side, you want to mount it, if it's BitLocker encrypted, that's not that easy. And yeah, if you run that, be comfortable to build your own kernel. There are distro images available from people that have been nice enough to build them for you, to install and so on. But if you really want to daily drive these things, you sometimes need to apply a different patch or like run a newer kernel or something like that. So as I said, it's not really for normal end users right now. But yeah. Okay, the one point about the USB-C connection. So initially we had problems like not being detected correctly with the hardware setup we had. I think that's all sorted out now. So that don't stand anymore. There are two things that I found quite interesting, or at least one I found quite interesting. So there's a small German company called Tuxedo. They are working on an X Elite based laptop, and they want to ship it with Linux by default. So it's not like a full product yet. They're working on that, but that could be an interesting part to figure out if they want to do that and they want to support that. That could be for anyone who's interested in running Linux on them. That could be an interesting part here. And as I mentioned before, we know that Dell and Lenovo are looking into these things. I mean, it's obvious that they have an idea of what's going on there, but how much effort they are going to put into that, I have no idea. My personal view, my personal hopes on that one are that I've been using Dell and Lenovo developer devices for quite a long time. So because I was never willing to like pay extra for the Windows license if I don't need that. And I would hope that at some point, maybe next generation or the one after, they would actually do developer editions of that one as well. And that would definitely mean an internal push in these companies to at least test the device, make sure all the things are worked out, work with the community, work with us to figure out like what firmware to push, what information we would need to like communication with EC or whatever, right? So that is a hope I have. I have no internal knowledge about that, but if the devices keep getting sold and getting more attractive, then I think at some point that will happen. Okay, so what do we learn? What is the summary here? So I'm more than happy to see that there's a full range of devices available, hopefully suiting a lot of needs for different people. So that was something I was very happy to see that when they launched, that it was not only one vendor, but quite a bunch of them. And the pain points for me is still the whole installation, getting that sorted. Afterwards, obviously, comes power savings and thermal and so on. We try to work with some of the distros to figure out how to do that, how to have like a scalable system there. For example, yesterday in the BOF, we talked about a little bit back and forth, what would be the best situation, like how to do the mapping and so on. But that's something that's still not sorted out. There's no solution. You can just go and grab a distro. So that's something that definitely needs work. But in general, the hardware support itself, that is quite good. It's stable, it's there. Some pieces are missing. Yes, we have a few bugs here and there, but in general, the hardware support for this device, for a very complex device, is already quite good. But as I said, it's for a tech-savvy early adopter who wants to enjoy that, who wants to play around with that, who always wanted to have an ARM laptop or something like that. It's fair to play around with that, but I wouldn't give it to my wife or something like that. So that's just too much pain for these people to work with, and yeah. And as I said, my hope is to have like Linux as an OS of choice by more manufacturers coming out, hopefully over the next couple of years or something. I don't have a timeline for that. And with that, I'm done with my presentation. Thank you all for attending. Any questions, comments, rants, flame balls? Yeah.
Thank you. What's your ideal end game for the stability of ARM64 laptops? Would it be completing the ACPI tables from the vendors to target Linux, or would it be device trees upstreamed for those specific devices with machine ID? Like, those are the different options you mentioned, but what's the ideal end game? Like, what would you like to see as a standard for long-term stability?
So actually we have been talking about the back and forth. So some people just prefer device tree. That's something we have been running in ARM for forever, right? My personal opinion is really, I would love to see like a full ACPI setup on these devices. Putting a lot of the knowledge that need to be understand just for the OEM or the ODM, putting in there, they can put it in there, export all the information out in the ACPI tables that we can use it from the Linux side and drive it from there. I think for a compute platform type of device that is feasible. I don't think that's something that is feasible for all embedded devices and so on. That's not working. But for compute, I think that would be a good compromise. But that's a lot of work. So that's a lot of work to get that done. As far as I understood, I haven't looked myself, but I talked to quite a few people also inside Qualcomm. It's also not about like only the implementation, also about the SPI specification might need to be adapted to actually support the way ARM is handling that compared to other things supporting ACPI right now. So in my personal opinion, I would love to go that way, but I don't see that it's going to happen within the next 2 years or something like that. So until then, I think we can go with DTB, and it's possible. Just like how we can make that work the best way for the user to actually get it started out. So yeah, so good.
Thank you.
Any more questions? There you go. Can you move it on?
Have you guys tried stripping out Gunya at all?
How to strip it out? I mean, it's in the firmware, so.
Well, I mean, you kind of showed or you talked about having SL bounce to sort of replace Gunya, which would then make me wonder why boot through it.
I mean, so first of all, SL bounce is not officially supported by Qualcomm or anything like that. So that is always difficult for us to like go and say we want to support that. That is the way we are pushing forward, because that would mean for every user who wants to do that, they would need to find the mechanisms to run SL bounce to actually boot into IL2 on the Linux side. That would solve quite a few problems. I agree on that front. But I want to support a device that's actually how it comes being sold basically off the shelf and so on. There's always like ways to tweak your system, but I mean, you can't really rip out Gunya directly. You can circumvent it by just doing the SL bounce trick, for example. But in general, yeah, we looked into and we tried and running this with IL2 to figure out what is working, what is making problems, what is not making problems. So for example, one of the things I have mentioned that there is, if you boot in IL2, your audio doesn't work. Because the interaction with the ADSP side is not able to upload the firmware binaries needed for the ADSP to actually get all the audio stuff working. There's an ADSP trimmed down version that is in the inside the ADSP when you're booting up, so you can do a little bit of stuff, but not the full audio stack and so on. So that, again, that's technology. It can be solved, but as long as Qualcomm is not saying, look, this is like the standard way of you supporting that, there's a little benefit of doing that, besides people who want to play with IL2, right? So yeah, so we haven't really done much work in that regard. We tested it out. We want to make sure that we understand like how it works, what is like the ways if you run SL bounce and so on, but yeah, that's not something we are completely pushing for. So. Okay. You have more questions or?
Oh, yeah. So what hurdles do you see getting TPM enabled? Sorry.
Oh God, honestly, I don't even know an answer for that. So
aside from UEFI
yeah.
and a whole bunch of other things, but just a standard TPM hardware module, forget VTPM and all the other.
Yeah. I don't know. To be fair, I haven't really thought about that because I mean that was like way off like the basic stuff that we need to get working. It's a good point. We need to understand that. I know that, I mean, on Windows side, they have like this full secure boot and everything. It is there. So basically, it just means to make sure that we can enable that on the Linux side. Obviously, we need the hardware support for the chips and so on. Make sure that that is working. I don't know if anything like on the UEFI side is blocking us to like run it like the Linux way we want it. That's something we would need to research and understand. So yeah. It's not really like a satisfactory answer, but
I knew it wasn't an easy answer, so thank you.
Okay, no problem. Any more questions? Anyone? So, you still have questions left since yesterday?
I do. I have many questions. But I just wondered, are you doing this for fun, or is Qualcomm paying you?
Okay, so no, it's part, right? So I was part of a small team that did a proof of concept, SOW, proof of concept on these compute devices. So we worked on that. Before we even started the normal landing team I'm now part of, actually did enablement on the Linux side and upstreaming quite a bit of the X Elite platform into the kernel. So a lot of this was already done by the landing team. Obviously, before that, Qualcomm does a lot of most of the code is written by the Qualcomm engineers, but then we help them to upstream that and get that all sorted out. That was something done by the landing team, and then we had how to look into the end-to-end use cases, what would be problems we need to solve, and so on, looking into the future. So that is so it was part of that ran out, but I'm still happy with the device, and a lot of my colleagues as well, and they haven't been part of that. So coming from the embedded background, working for Linaro, which does ARM, there's obviously a drive in ourselves that we want to have these kind of devices as our daily drivers. So it's both of it, right? Okay. Oh, go ahead.
How much can you glean from the Android stuff? Because there's obviously Android. I'm not aware of any.
Yeah. So okay. So for Android. So for the specific X Elite chip SoC, I'm pretty sure that they might have an internal Android port on that, but there are no Android devices with this kind of chip, right? So that's something. And there's always changes in architecture, if you do this kind of bigger moves to different SoCs and so on. So a few things are similar between Qualcomm devices growing over the years, but there are differences here that we can't get any information on the Android side or something. So for example, when we do other enablement of mobile platforms, mobile SoCs or something, we can really look into all the downstream sources that Qualcomm prepared and make sure we can work with that and get that upstreamed and change and so on. There's no downstream in that case for the compute side. Okay. So thanks a lot. I hope you have a nice rest of the day and enjoy the conference.